Now we need to look at the relationship between RAM and ROM and the CPU. For the CPU to process information, the data must be stored in RAM or ROM. The function of ROM in computers is to provide information that is fixed and permanent. This information, such as tables or character patterns to be displayed on the video monitor, or programs that are essential to the working of the computer, such as programs for testing and finding the amount of RAM installed on the computer, or for displaying information on the video monitor. In contrast, RAM stores temporary information that can change with time, such as various versions of the operating system and application packages such as word processing or text calculation. These programs are loaded from the hard drive into RAM to be processed by the CPU. The CPU cannot get the information directly from the disk because the disk is too slow. In other words, the CPU must first seek the information to be processed from RAM or ROM. Only if the data is not there does the CPU seek from its mass storage device, such as a disk, and then it transfers the information to RAM. For this reason, RAM and ROM are sometimes referred to as the primary memory, and disks are considered the secondary memory. Your removable hard drives, your thumb drives, these types of devices are typically your tertiary memory. A program stored in memory provides instructions to the CPU to perform an action. The action can simply be adding data to payroll or controlling a machine such as a robot. The function of the CPU is to fetch these instructions from memory and execute them. To perform the actions of fetch and execute, all CPUs are equipped with resources such as the following. Foremost among the resources at the disposal of the CPU are a number of registers. The CPU uses registers to store information temporarily. The information could be two values to be processed or the address of the value needed to be fetched from memory. Registers inside the CPU can be 8-bit, 16-bit, 32-bit, or even 64-bit registers, depending on the CPU. In general, the more and bigger registers, the better the CPU. The disadvantage of more and bigger registers is the increased cost of the CPU. The CPU also has what's called the Arithmetic Logic Unit, the ALU. The ALU section of the CPU is responsible for performing arithmetic functions such as add, subtract, multiply, and divide, and logic functions such as and, or, and not. Every CPU has what's called a program counter. The function of the program counter is to point to the address of the next instruction to be executed. As each instruction is executed, the program counter is incremented to point to the address of the next instruction to be executed. The contents of the program counter are placed on the address bus to find and fetch the desired instruction. In the IBM PC, the program counter is a register called IP, or the instruction pointer. The function of the instruction decoder is to interpret the instructions fetched into the CPU. You can think of the instruction decoder as a kind of dictionary, storing the meaning of each instruction and what steps the CPU should take upon receiving a given instruction. Just as a dictionary requires more pages, the more words it defines, a CPU capable of understanding more instructions requires more transistors to design. And so here you can see the overall structure of the inside of a CPU. They can be 8-bit, 16, 32, 64. They will vary, and we'll notice that in our microcontrollers as well. The ALUs can do all of these functions. The program counter, looking at the next instruction to execute, keeps track of where it is in the program. The instruction decoder then interprets the instruction fetched by the CPU.